Hey guys, welcome to another fun day of math. This is Tuesday, the 17th. Happy St. Patrick's Day. And we're going to talk about 10.4 inscribed angles. Inscribed angles. So we're going to find the measures of what's called inscribed angles and find measures of angles of inscribed polygons. So before we talked about this, and I'm just going to get a circle going here real quick. We had another kind of angle that, of course, was called a central angle, and it had rays that would come from the center and have its vertex at the center of the circle. So this was a central angle. The example that we have to the right, you'll notice that we have an angle drawn in there. We have angle QRS, but it does not have its vertex at the center of the circle. It has its vertex on the circle, and it's drawn inside, so it's a central angle. But this one is called an inscribed angle. So we have a central angle with its vertex at the center, and then we have an inscribed angle whose vertex is on the circle. As a result of these angles, or as part of these angles, we have, in this case, we have an arc here, and you'll see we have an arc QS over here. And it says an intercepted arc has its endpoints on the sides of an inscribed angle and is in the interior of the inscribed angle. So for this arc, this one we just really called it an arc. And we know that its measure is equal to the central angle. For this one that is intercepted, or you can see that RQ, if we continued, would go right through the circle there and cut the circle at point Q, and the same thing is going to happen to RS, and then we have arc QS. When an arc is formed by an inscribed angle, it is called an intercepted arc. So lots of terminology here to get straight. We have some different scenarios here for our intercepted arcs. In the first case, we have an inscribed angle, so its vertex is at the center of the circle, or no, I'm sorry, the vertex is on the circle, and one of the rays goes through the center, and here's the other ray, and then that creates this intercepted arc right here. Another scenario that we could have in case 2 is where we have an inscribed angle with its vertex on the circle, but you can see that the center is inside the arc. Okay, it's between the two rays, and then or inside the angle, and then we have an intercepted arc there. Or maybe we have an inscribed angle and it's just all over to one side, and it doesn't go through the center. One of the rays doesn't go through the center isn't between, it's on the outside, but we still have an intercepted arc there. So those are all inscribed angles and their intercepted arcs. So the inscribed angles also have measures just like the central angles do, just like the arcs do. And so our rule for this is that the measure of the angle is 1/2 the measure of its intercepted arc. So just something to think about for a moment. If I were to draw in the central angle here, let's see if we can get it to draw a little bit better. So I'm going to draw in a central angle. That's pretty good. And we know that the measure of that central angle and the measure of the arc are the same. So we'll call this C here, and I'm going to call this point F. So the measure of AB, arc AB, is equal to the measure of the central angle, which would be ACB. So they're the same. And it tells us that the measure of the arc is double the inscribed angle. Well, here's what happens. You can see, I'm going to move my angle here just a little bit and turn it around and try to get it lined up. If it'll let me. And hopefully you can kind of see there that when I move the green angle, which was the central angle, it is much, I didn't change the size of it or anything, but it is much larger than the inscribed angle, angle 1 there. And in fact, it's double the size. And so see if we can move him back a little bit. And so what we find out is that the measure of the inscribed angle is 1/2 the measure of arc AB, or 1/2 the measure of the corresponding central angle. All right, example 1, it says find each measurement. And so we have a picture there to the right, and we want the measure of angle P. So angle P would be this one right here. Well, if I take that angle and I follow along the rays from that vertex, I can see that it intercepts my arc, or my circle, with arc MN. And so the rule is that the inscribed angle, which P is an inscribed angle because it has its vertex on the circle, the measure of angle P we'll get this right here in a second. The measure of angle P is going to be equal to 1/2 the intercepted arc, and the intercepted arc is MN. So the measure of angle P is 1/2. The measure of MN was 70 degrees. So the measure of angle P would be then 35 degrees. It is half the measure of the arc. Okay, so for the next one, for B, it says we want the measure of PO. Arc PO, which is this one. So what I'm going to do to kind of determine what angle created that is I'm going to follow from the endpoints to the vertice of the angle. So I can see that P, it actually goes in 2 different directions, but point O only goes in 1 direction. So I'm going to start there so that I only have one way to go, and I see that it leads to vertex N, and then I can follow from N to P and get my angle. So arc PO is related to angle PNO. Again, I want to kind of set up a little equation here. And so the measure of the intercepted arc, or I'm sorry, the measure of the inscribed angle, which is PNO, is equal to 1/2 the intercepted arc, which is the measure of PO. So I want to use the rule to set up the equation. Okay, the the measure of the inscribed angle is equal to 1/2 the measure of the intercepted arc. And then I can plug some parts in. So our angle is 56 degrees, and that's 1/2 times PO. So when I have 1/2 times something, taking half of something is the same as dividing it by 2. So if I multiplied both sides by 2, then that would give me the measure of PO. So the measure of arc PO is equal to 112 degrees. So it should be bigger than its inscribed angle. I've got a couple of more practice problems there. I have arc CF. So arc CF is here. Again, I have a scenario where I want to figure out what inscribed angle is associated with it. I do want to say one thing here. Some of us are going to look at this intersection and go, oh, there's a right angle and that's 90 degrees and that's a central angle, da da da. It kind of looks like it could be, but there's no indication that that is a right angle. Just because it looks like it doesn't mean it is. You have to have the little box in the corner, or you have to have the angle measure itself. And that intersection, although for some of you it may look like it's a central angle, that is not the center of the circle, and the center is not indicated there. So we can't use that as a central angle, or we can't make the assumption that it's a right angle. So I'm going to go on my arc CF. I'm going to look at endpoint C and endpoint F. Well, C goes 2 different directions. So I'm going to start with F because it only goes one direction. I'm going to follow up here to vertex D, and then I can see, well, I could go from D to C then, and my angle that's associated with arc CF is 40 degrees. Again, I'm going to use what we know, or we're going to use the theorem that says the measure of the inscribed angle. So the measure of angle CDF is equal to 1/2 the measure of its intercepted arc, and it's intercepting arc CF, which is the thing that we want to know. And then we can plug in. So CDF was 40 degrees equals 1/2 times the measure of arc CF. And then to get CF by itself, we're going to, instead of multiplying by 1/2, or trying to divide here, 1/2 of something is the same as dividing by 2, so I'm going to multiply by 2. And I get 80 is equal to the measure of arc CF. So there's another example. Okay, last one in this section. It says we want the measure of angle C. So if we look at vertex C, we see that it goes from C to E and C to D. So this is my angle. I don't know what the value is. I don't have any right angles in this picture. But if I follow along those, I see that I end up at points D and E on the circle, and so between those is my intercepted arc. So my equation would be set up like this. The measure of angle C is equal to 1/2 the measure of arc DE. And so the measure of angle C is 1/2 times 98. So we want half of 98, which is 49 degrees. All right, the next one, I'm still looking at inscribed angles. This is just telling us about congruence. So if 2 inscribed angles of a circle intercept the same arc or congruent arcs, then the angles are congruent. So I'm just going to follow along with this. I've got angle B and angle C. Angle B intercepts the circle at points D and E. And so you have intercepted arc DA. And then the same thing happens here at angle C. C intercepts the circle at D and A as well. And so it also has an intercepted arc of DA. So we know that something is congruent to itself. So the arc that they're both intercepting is congruent to itself. So therefore, the angles themselves have to be congruent to each other. So for instance, if DA was 60 degrees, and we know the arcs are half of that, then angle C would be 30 and angle B would be 30 as well. So that's how they're equal. So if A and C, or B and C both intercept the same arc, then B is congruent to C. Example 2, use inscribed angles to find measures. So we have angle T. And angle T here, if we follow along, we can see that it intercepts VS. And I also see that U also intercepts VS, which makes those two angles congruent to each other. Okay, so angle T is congruent to angle U, which means that the measure of angle T is equal to the measure of angle U. And so I can substitute the expressions that represent those. I have 3x minus 5 for angle T is equal to 2x plus 15. And I'm going to solve for x. So I get x minus 5. If I subtract 2x, I get x minus 5 equals 15. I'm going to add 5 and get 20. So I get x is equal to 20. However, and that's important, however, I actually want the measure of angle T, which is 3x minus 5. And so we're going to substitute that 20 in for x, which is 60 minus 5, or 55 degrees. And there's the measure of angle T. Inscribed polygons. So this is when we have a figure that's drawn inside a circle with its vertices on the circle. In the first theorem here, it says an inscribed angle of a triangle intercepts a diameter or semicircle if and only if the angle is a right angle. And actually, we talked about this the other day, that if I have a right triangle inscribed in a circle, the hypotenuse is the diameter. Well, you can see here that in this triangle, this side is a diameter, which means that this angle has to be 90 degrees here, and the opposite is true as well. And the reason for that is that on the diameter on FH, if we were to give this C a center here, if we were to say that C or FCH was an angle, its measurement would be 180 degrees because it's a segment or a line. It's also a central angle because its vertex C is at the center. And we know that then this arc is also 180 degrees because central angles and arcs have the same measure. So how does that work for this? Well, you can see that this inscribed angle FGH intercepts that same arc FJH. And so an intercepted arc is half, or the inscribed angle is half the measure of the intercepted arc. So it's going to be half of 180, which is 90 degrees. And you can see there that we have our right angle. All right, so we have an equation or a problem here where I have a triangle drawn or inscribed in a circle. I see that I have one side of that triangle is the diameter. So that means that angle G here has to be a right angle. So this must be a right triangle. We want to find the measure of angle F. Well, we keep in mind, again, we have a triangle here. This guy right here. And what do we know about the angles of a triangle? The triangle angle sum theorem says that the angles always add up to 180 degrees. So the measure of angle F plus the measure of angle G plus the measure of angle H is going to equal 180. So we're going to use that idea here to solve for x and then ultimately solve for the measure of angle F. So F is represented by 4x plus 2. The measure of angle G, we actually already know that is 90 degrees since it's a right angle. And H is 9x minus 3, and that equals 180. So we have to go through and combine our like terms. We have 4x and 9x is 13x. And then our constant terms are our numbers without variables. We have 2 and 90, so 92 minus 3 is 89 equals 180. Okay, and now we can solve for x. So we get 13x is equal to 269. And then we're going to divide by 13. Hang on just a minute. Oh, gotta watch me there. I was like, well, this isn't working out quite right. We want to take 180 minus 89. So if I take 180 minus 89, I'm going to get 91. That makes a lot more sense. And so then when we divide by 13, x is equal to 7. And then we'll do the measure of angle F. So angle F is 4x plus 2, so we're going to substitute that 7 in for 4. And we get 4 times 7 plus 2 is 30 degrees. Okay, last concept here in this lesson is that we have, it says if a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. So on the right we have a circle A with quadrilateral LMNK. And it says if a quadrilateral, so it can only have 4 sides, doesn't matter what it looks like in there as long as the vertices are touching the circle, then opposite angles are supplementary. And so my opposite angles in this case would be L and N and K and M. So if they're supplementary, that means that the measure of angle L plus the measure of angle N would equal 180. And the measure of angle K plus the measure of angle M is equal to 180. So we're going to test that out. It says quadrilateral WXYZ is inscribed in circle V, so it is a quadrilateral. And like I said, opposite angles are supplementary when we have that. So these guys would be supplementary, and let's pick a different color here. These guys would be supplementary to each other. We want to find the measure of angle X and the measure of angle Y. And so if I'm looking at the X there, the red ones, the measure of angle Z plus the measure of angle X is equal to 180. And so we know that Z is 60. And then to solve for the measure of angle X, we're going to subtract 60, which is 120 degrees. So there's X, and then we can do the same thing for Y. So I have the measure of angle W plus the measure of angle Y would be 180 because they're supplementary. 95 plus the measure of angle Y is 180. And then if I subtract 95, the measure of angle Y would be 75 degrees. Just kidding. How about 85 degrees? 85 degrees. Okay, those are our notes, and we do have an assignment to work on for those. Actually, I'm going to change what's written up there. So make sure you go to the assignment page to check the problem numbers and to see what they are. Okay. thanks for playing today. Have a good day. Do your work. Um, just try your best, guys. And I will see you tomorrow. Bye.